Hi trig students, this is section 9.4. It's on vectors. I don't think you're going to find it difficult at all. I think these last two sections of trig are going to be a nice little break for you. So let's just hop right in. We have a lot of terms to learn on these first few pages. So in trig speak, a scalar is just a number, like 45 pounds. It's just simply a number, or 10 pounds. A vector, however, a vector quantity has a magnitude, which is a number, and a direction. So that's a My Math Lab question. So for example, it has an amount or a magnitude and a direction. This would be a vector because you have an amount and a direction. Sometimes your direction is just your theta, just your angle, okay? So there's two ways to represent vectors. They could be bold, or they could have a little arrow over the letters, okay? So this is supposed to have a little arrow right here, actually. I guess somehow he floated up there. But bold OP and the little arrow over OP both represent the vector OP. Okay, so let's talk about this little OP vector. The first letter represents the initial point where we start. The second letter represents the terminal point where we end. So this is vector OP because we start at O and we end at P. And you know we end at P because that's where the arrowhead is. This is a very different vector. This is vector PO because we start at P and end with the vector head or the arrowhead, which is at O. Okay, so they're not the same. They have the same magnitude, meaning the same length, but they're in opposite directions, so they are not the same vector. Okay. Now vectors are commutative, so it doesn't matter who goes first if they're added together. And for every vector v, there is a vector negative v that goes in the opposite direction, so that when you add them together, you get 0, or the 0 vector. This is also a My Math Lab question. Okay. And then the scalar product of a real number, or a scalar, and a vector is just the two of them multiplied together. Okay. Now we get into a lot of very detailed vector situations happening here, but all you're going to need to know is that if this little arrow is u, then 2u is just twice as long. 3 halves u is 3 halves times u. Half a u would be half as long as u. And then if this one was positive 2u, this one is negative 2u. Same magnitude, right? Same length, but opposite direction because it has that negative, so it's going the opposite direction. Okay. All right, let's talk a little bit more. Most of this is sort of overkill for this section, but I put it in here just so that you would have it at some point if you needed it. Okay. So two vectors are equal if and only if they both have the same magnitude and direction. Okay. Now let's say that we have two vectors. Let's say we have vector A, it's right here, and we have vector B, it's right here. If we want to add them together, we're going to start with A. Here's his initial point, here's his terminal point. At the terminal point, at the arrowhead, we start B. Okay. Then the sum of A, B is also called the resultant. And to find the resultant, we can do two different things. We can start at the initial point of A, where the whole thing started, and go to the terminal point of B, where the whole thing ended. So we took A, we added B to it. Our answer, or the resultant, is this one, A plus B. It started at the beginning of A and went to the end of B. Another way to do this is make a parallelogram. This is called the parallelogram rule. Here's A. Then we take and put B on each end of it. Okay. And then we connect those two B's with another A. What we've done is made a parallelogram. Then this diagonal across the parallelogram, because this is an A, here's B, this diagonal across is the A plus B, and you've made a parallelogram. This is a little bit overkill for me. I'm not sure why you would do this in this particular class. It's a lot of work. This is the way that I like to do it. I think it's the easiest way to go about it, so that's what we're going to do in our examples. Okay. All right, so another way to write a vector is to have these funky little sort of hexagon looking sides. Okay. This tells you the initial point and the terminal point of a vector. Let's say we wanted to add two vectors together. Well, you would add their initial points, and then you would add their terminal points, and that would be the new vector. Okay. If you had a vector and you had a number out front, a scalar, if you wanted to multiply them together, you would just multiply that scalar by each component of the vector. Okay. Let's say that you had a vector A that looked like this. Well, negative A would be just like distributing a negative through vector A. And last but not least, if you wanted to subtract them, remember subtraction always has a hidden step. So you're really putting a minus sign through both of those. So really what you have is A, B plus minus C minus D. Okay, so that what you end up with is A minus C, B minus D. Okay, we're going to practice all these with real numbers in case this is too strange to really help you. Okay, now also sometimes they want the magnitude and the direction angle of the vector. Okay, if you had the vector AB, okay, to find the magnitude, for some reason my paper's only printed one little line, but the magnitude of a vector has 2 bars on each side, because 1 bar on each side looks too much like an absolute value. So this indicates the magnitude. All we're going to do is take the square root of each part of the vector. Okay, and it's always positive. To get your theta or your direction angle, you're going to take tan theta equals the B, the Y component divided by the A component, and that will help you find your theta. Remembering also that sometimes you have reference angles, so you need to be conscious of your quadrants so that you're in the right place. Okay, one last page of lecturing, and then we're going to jump right into our examples. Okay, lots of my math lab questions on this page. We also have what we call a unit vector. So a vector, let's say his name is U, okay, for which his magnitude is 1, remember this is magnitude, is called a unit vector. So that's my math lab question. How do you get a unit vector? Well, you find the magnitude, and then you take the vector and divide each component by the magnitude. We're going to practice that as well. Okay, more math lab questions. Let's say you have a vector. He's a little algebraic vector. It means that his components are algebraic components, okay, whose initial point is at the origin. So you have a vector who's coming out of the origin. Then that vector V is called a position vector, okay? And then last but not least, you can also write your vector with horizontal and vertical components, okay? So A would be the horizontal component, and it sits next to I. This is not an imaginary situation. I'm having problems remembering how to spell imaginary. I'm going to put that. Not imaginary. Okay, so I means the horizontal component, J means the vertical component. So A would be whatever you're doing horizontal. B would be whatever you're doing vertical. So this is not an imaginary eye. Remember, an imaginary eye kind of looks like this. That's not the imaginary eye there. All right. Okay, those are my math lab questions. So we can also go through here and just make these corrections, okay, making sure that you realize these should be double lines because these are magnitudes and not absolute values. So it's a little different there. Okay, I think we're ready. We're ready to start our examples. There's not too many on here. They go pretty quickly. All right, example 1. Use the vectors given to graph the following. Well, you don't even have any vectors given because I forgot to put them on there. So let's do that. Okay, so let's say that we have a vector W that kind of looks like this. And let's say we have this nice little horizontal vector V. I'll make him a little longer. That looks like that. Okay, there we go. So given these vectors, graph this. That just means let's make a picture. That's all that wants us to do. Okay, so you can leave it like this, or you can rewrite it knowing that what you want is V plus a negative W. This is a negative W, which means we want the opposite direction of W. That's what we want, okay? So we're gonna start with V. Here's our V, we drew V. Then we're gonna add to him the opposite W, the negative W. So I'm gonna start here. I'm not gonna go up for positive W. I'm gonna go down negative W, okay? Then my answer, my V minus W, is gonna be what connects from the initial point of V to the terminal point of negative W. This is V minus W. This is your graph, okay? So V minus W is the vector from the beginning of V to the end of W, okay? So we did V minus W, and then we connected those 2 points, and that is your V minus W. So you could have made a parallelogram if you wanted. You could have had V, then you could have had minus W, right, on both ends, okay? And then we could have had another V, right? This is the parallelogram if you like it better. And then we would start here and make this diagonal, and this would have been V minus W. So this is another way to do it, but this is how you're gonna see it in my math lab, okay? It's just like this. All right, example 2. The vector V has an initial point P and a terminal point Q. Write V in the form AI plus BJ. This means find its position vector. Okay, so I'm gonna label P, since that's the initial point, I'm gonna call it X1, Y1. I'm gonna call Q, it's the terminal point, X2, Y2. What I'm looking for is X2 minus X1I plus Y2 minus Y1J. All I'm doing is subtracting them. So here we go. I'm going to have 9 minus 0I plus 10 minus 0J. And my vector is going to be 9I plus 10J. And there's my answer. Okay. All right, we're going to do the same thing here, but we are not starting at 0 any longer, right? We want to find the position vector. We want to find what would happen if we did start at the origin. So we're going to replace these. We're going to label them X1, Y1, X2, Y2, because this is our first point. This is our terminal point. okay? We're going to have x2 minus x1. 5 minus a negative 6i plus negative 7 minus a negative 8j. So I'm just following along with this formula. I'm going to clean it up. 5 minus a negative 6 is 5 plus 6. Whoops, that's an I. Negative 7 minus a negative 8 is like plus 8. That's 1. J. You don't have to put the 1. In fact, my math lab might mark you wrong. And there you go. All right. Not hard at all. Okay. It's almost just like combining like terms is basically the name of the game. Okay. Example 4. We're going to do it one more time. Okay. So we have x1, y1, x2, y2. Our vector is going to be x2 minus x1, I. y2 minus y1, j. This gives us negative 6i plus 8j. And there we go. Okay. All right, so next up on the agenda here, magnitude. So remember, the magnitude of your vector is just going to be x squared plus y squared. You take the square root. Now your book likes to call these a's and b's, but I think introducing a whole nother letter at this point is kind of silly. So I always call them x's and y's. Okay, so the magnitude of v is going to be 5 squared plus negative 1 squared. That's going to be 25 plus 1. That's the square root of 26. And there's nothing we can do about the square root of 26. You can try to reduce it and see if it goes down lower. You can make a factor tree. The only thing that'll go into it is a 2 and a 13. And they're both prime, so we can't go any further. We don't have any numbers that have 2 of the same, so we're done. Okay, let's try it here. All right, our magnitude is going to be negative 9 squared plus 2 squared. That gives us 81 plus 4, square root of 85. Believe it or not, that is also as reduced as it gets. If you try, the only thing you can pull out is a 5 and a 17. And again, you don't have any numbers that have 2 of the same. So we leave it with the square root of 85. Okay, that brings us to example 7. Okay, now let's talk about some scalars for a little bit. All right, so here we have vector v and we have vector w. We want 6 times v, 7 times w, and then we want to add them together. Okay, so 6v is simply going to be 6 times each component of v, just like that. So 6v is going to be 42i minus 54j. We're just going to distribute it. That 6 is a scalar and we just push it through. Okay, 7w is going to be 7 times negative 6i plus 4j. That's our vector w. We're going to distribute it through. We get negative 42i plus 28j. Okay, so now we're going to have 6v plus 7w. So we're going to have this vector, this is 6v, plus this vector, negative 42i plus 28j. Well, these actually cancel, and then we're left with these. All we're going to do is combine like terms. Negative 54j plus 28j is going to give us negative 26j. And that's our answer. Okay, 8 and 9, we're going to focus on some magnitudes and some order of operations, making sure that we're comfortable with all of those. Okay, we already know what a magnitude looks like. This wants us to find v minus w first. That's what's inside. Once we find that vector, then we're going to take the magnitude of it. So our first step is going to be v minus w. So I'm going to have negative 3i plus 2j, that's my v, minus my w, 3i minus 5j. Now I did it like that because I wanted to remind you that there's that secret step where we have to distribute that negative through there. So we're going to have negative 3i plus 2j minus 3i plus 5j. Watch your signs there. Negative 3i and negative 3i are negative 6i. 2j plus 5j, 7j. So now we have the vector v minus w. Now we want to find, our second step is to find the magnitude of that new vector. So we're going to take negative 6 squared. We're going to take positive 7 squared. That's going to give us 36 plus 49. And we get the square root of 85. And remember, we'd already said on the last page that there's nothing we can do about that. It is what it is. Okay, there we go. Okay, example 9. Now notice the difference here. Here we found v minus w and then took the magnitude. Here they want the magnitude of v, the magnitude of w, and subtract. So here we're going to find the magnitude of each first. That's the key. Okay, so make sure you can see the difference in these two. All right, so first thing we're going to do, let's find the magnitude of v. So I'm going to have negative 4 squared plus 5 squared. That's going to give me 16 plus 25. And the magnitude of v is the square root of 41. Okay, I can't reduce it or do anything with it. It is what it is. Okay, now let's find the magnitude of w. I'm going to have 2 squared plus a negative 3 squared. That's going to be 4 plus 9. That gives me square root of 13. Again, nothing I can do with that. Okay, now if I subtract these two magnitudes, I get square root of 41 minus square root of 13. And I am done. That's the best I can do. I know that's ugly and it's not very elegant, but that is the end of it. So stop when you get to that point. Okay. All right. Let's go on to example 10. Okay. Now 10 and 11 deal with unit vectors. So a unit vector is simply a vector that has a length of 1 unit. Okay. So how do we find a unit vector? Okay. Well, a unit vector, you take the vector that's given and divide it by its magnitude. So I have a given vector. I'm going to need its magnitude. So I'm going to have the square root of negative 12 squared plus negative 5 squared. That's going to give me 144 plus 25, which is square root of 169. Square root of 169 is 13. Okay, I have my magnitude. Now, for my unit vector, I'm going to take v, the vector that I see here, and divide it by the magnitude. And then I just clean it up. So I want to make two separate parts. There's my I part, and here's my J part. Okay, I just split it up under each one, reduced it the best I can, and that's my unit vector. And most of the time, it is going to be a fraction, some kind of nasty little fraction. In fact, let's check out number 11. That brings us to this one. Okay, so same directions. We want a unit vector having the same direction as V. Okay, so I need the magnitude. I'm going to have 4 squared plus negative 7 squared. That's going to give me 16 plus 49. That's the square root of 65. Unfortunately, that is unable to be reduced. That's it. Now, you can probably already guess what's going to happen. This becomes a denominator. You can't have a root in a denominator, so we are going to have to rationalize one of these ugly little guys. Okay, here we go. So I'm going to take V. This is my unit vector, divided by the square root of 65. Okay, so here we go. I'm going to have 4 divided by the square root of 65, that's my I, minus 7 divided by the square root of 65. That's my J. All right, I'm going to come down here. I'm going to take this little component here, and I'm going to rationalize him sort of over here out of the way. And he becomes 4 square root of 65 over 65. So 4 square root of 65 over 65, I. Okay, so that's that. Let's do this one now. I'm not worried about his sign because I already put it in over here. Let's rationalize the little J component. Gives me 7 square root of 65 over 65. And that's my J. And there's my answer. So again, it's not pretty, but that's it. It's not a hard process. Okay, well, we have dealt a lot with magnitude, but we discussed the fact that the definition of a vector is that it has a magnitude and a direction. So let's talk a little bit about a direction now. So we want to write a vector in this form. We have a magnitude, and now we have a direction. With vectors, sometimes they use alpha rather than theta. So I just wanted to throw that out there for you, just so that you realize it's still an angle. You still have it. It still could be on the unit circle. It's just that for whatever reason with vectors, they like to use alpha rather than theta. Okay, so my formula I'm going to use is that the magnitude times cosine alpha I plus sine alpha j gives me my vector. Okay, so my vector is going to be 20 times the cosine of 120 degrees I plus the sine of 120 degrees j. Now we are not done because it doesn't look like this yet. We need to get rid of this cosine sine, which means we need to find 120 degrees on the unit circle. Here it is. This is the cosine of 120 degrees, negative 1/2. This is the cosine, this is the sine of 120 degrees, root of 3 over 2. We need to replace with those. So cosine of 120 was negative 1/2, there's our I, plus the sine of 120, that's root of 3 over 2, and there's our j. Okay. Now we're going to distribute this 20 through here. 20 times a negative 1/2 is negative 10i. 20 times root of 3 over 2 is going to reduce to 10 root of 3j. Oh, I forgot my plus in there. And there's your answer. Okay, so we just plopped our little information right into here. We went to the unit circle. Notice we went back to degrees with vectors. We're back in a degree situation. Then, once we reduced these down to their actual points, we distributed that 20 through there, and we came up with our vector. Okay, last page. Told you these were short little sections. Okay, last 3 questions. Okay, a couple of these are a little bit long, but here we go. All right, so for example 13, they give us the vector. It's kind of an ugly vector, but they give us a vector, and they want you to find the direction angle. They want you to find alpha. Okay, well, first thing we need to do is think about how this plays out. Here's our x, here's our y, okay? So we have a little vector of -5 root of 3, comma, 5. That's our actual vector. If we were to graph him, we would have a -5 root of 3, +5, somewhere up here in quadrant 2. That's important to remember, right? We need to make sure that we end up with the direction angle that's in quadrant 2. Okay, here's our x, here's our y. Now, we're going to take tan of alpha, I almost said theta, but we're finding alpha. That's going to be y over x, so it's going to be 5 over -5 root of 3. That's going to reduce down to -1 over the square root of 3. Now, I don't need to rationalize this. In fact, it's easier if I leave it, right? What I want to do is look at my unit circle. I want to know for what angle, for what alpha, in quadrant 2, does tangent equal -1 over the root of 3. Now remember, tangent is y over x. So I'm over here in quadrant 2. Here are my choices. It is not going to be this one because y over x would give me a -1. So it's either going to be -1/2 over root of 3 over 2 or -root of 3 over 2 over 1/2. The placement of your square root of 3 is the key. This has a root of 3 in the bottom. Well, if it's y over x, it means your x should have the root of 3 in it. This term has the root of 3 in the x. This one has it in the y, or the sign. So what we're looking at is actually 150 degrees because, again, we're degrees when it comes to vectors. Okay? All right, so that's going to mean alpha, I almost did it again, is 150 degrees. And there we go. Okay? Now, you could have found r. That would be like your magnitude. You could have tried to do cosine and sine, but it's just as easy to approach it this way to get your alpha. Okay, now, same problem. Find the direction angle. We're finding alpha for both of these. This one worked out nicely. We were on the unit circle. We will not be on the unit circle here. We're dealing with reference angles again, this time with degrees. So we need to make sure that we can do that. Okay, here we go. I've got an x of 9 and a y of -6. Let's check my quadrant. +9, -6. I'm going to be down here in quadrant 4. Okay. I'm going to do tan of alpha is y over x. That's -6 over 9, or -2/3. That is not on the unit circle. So I know I'm going to have to use reference angles. If my reference angle were in quadrant 1, I'd be good to go. My reference angle for degrees here is 180 minus. Here, 180 plus. In quad 4, where I want to be, I'm 360 minus. Okay, so I want to be in degree mode. I know we're hopping all around like crazy, but vectors use degrees. Then I'm going to do inverse of tan of 2/3. I did not put negative 2/3 because that's going to mess up my reference angle. I just put positive 2/3. Okay, so here we go. Go back to where we were. Okay, I'm going to go to mode. I got to get to degrees. Now I'm in degree mode. Quit. Second tan, 2 divided by 3. Here we go. 33.690. Okay, that is in quadrant 1. That's my reference angle. 33.690. That is my reference angle. I want to be in quadrant 4, so alpha is going to be 360 minus 33.690. When I put that in my calculator, if I use 1 decimal place, I think that's what my math lab asks for, you get 326.3 degrees. There you go. Okay, let's try one more of those in a different quadrant this time. All right, here we go. We have an x of -7, a y of -9. Okay, -7, -9. I'm down here in quad 3. Okay, I'm going to take tan of alpha is going to be y over x. That's 9/7. Not on the unit circle. I don't have to make it a positive, it already is. So I'm going to take inverse tan of 9/7. Remember to be in degree mode. That's going to give you 52.125. That's quadrant 1. That's your reference angle. Okay, so how do I get my actual angle in quadrant 3? 180 plus your reference angle. So alpha is going to be 180 plus 52.125. And my math lab is going to ask for 1 decimal place. And you get 232.